Okay, so our project is going to be something similar to a water turbine. We're going to use hydroelectricity. And what hydroelectricity is, it's just basically the production of electricity through the flow of water, through the current.
A water turbine is a rotary engine that produces energy from moving water.
Lester Allen Pelton created the Pelton wheel, which was one of the first water turbines that we know of.
It was like the one that gathered water and like the big wheel, This kind of techniques of clean energy are widely used. They were widely used prior to electricity being used
For like mills and whatnot, like sawing wood,
Yeah,
they would
for
use
farms.
water mills. And then the ocean currents are continuous directed movements of water generated by the forces upon this mean flow.
So for the water turbines to work, we need ocean currents.
What about your innovation? What is it about?
Alright, it's gonna come.
Yeah, it's
How is it gonna work is that the underwater current produced by the tides spins blades arranged like an airplane propeller. These turbines are attached to a gearbox, which is connected to an electrical generator. This produces electricity that is carried by the cable to the shore. Once it's plugged into an electrical grid, electricity can be distributed throughout the whole nation.
And water has a high density, which means that the same amount of energy can be produced by an underwater turbine as a windmill, but at slower speeds and over less area.
So water turbines work efficiently as a wind turbine.
So you don't need the speeds of the wind in order to create as much energy.
So for our innovation, we want to make something similar to a wind turbine, but that goes on the water, and that's cheaper to make and smaller. And you use a flow of water, so high currents to power it and produce electricity.
And also, like the advantage of having a water turbine is that wind turbines require a lot of land, and like windmills, and it takes a lot. It's very expensive. And water turbines, I mean, there's 70% of the earth is water, and we're not using all of it, and we can use all the water.
So
And these are some pictures.
this is like a picture we found that we want to make something similar. Like we want to do something like this, but without this tower right here.
Essentially like an underwater kite with water turbines on it that would be
Yeah, it's just
anchored to the seafloor, and then it would be in the currents, and because of the currents are flowing, it would move. Whenever the currents move, the kite would move with it. So it's sort of like a single airplane wing with two turbines on it, or one turbine, and then it spins the turbine, it goes through the cables, and then it goes to power grid, and it goes back to shore.
So it's gonna be kind of similar like this, but
This is like a concept art of some kites that people have designed.
and instead of like the cables going like to one point, they're gonna go to different points, and they're gonna meet at like at one point.
Yeah. Just
And
a
the good
bunch
thing
of-
is that ocean currents are always in the move, and it will always have kinetic energy to make electricity. And wind turbines, when there's no wind, they don't work.
And you don't have to worry about creating like massive 100-foot tall towers
Yeah.
to
Yeah, it's
reach the high-speed winds.
They can be really slow.
If
They
you
are
want-
It
really
sounds
small.
like a very intriguing idea. My question is, how does it take that constant energy? I mean, even at night when the water is relatively calm, or low tide, there's still a lot of energy in the water, right?
Yes, because it's
How's it going to convert that to electricity?
Because it's spinning a turbine, which is also spinning a gearbox, and
But
it works the
It's
same.
not spinning it at a constant rate, right?
No.
but it doesn't have to, because water is denser.
Well,
Right.
it's just
So because water's denser,
I mean,
it'll move that?
it was always been the move.
Okay.
Yeah, and as we said, we want to make it cheaper and easier to market. And it's like wind turbines are more expensive to make. You have to produce like large towers, and it's very expensive to make. And we want to market like a cheap but good product.
Right.
Let's start tackling.
Alternate use of energy for a cleaner and greener tomorrow. Very broad statement. Okay. All right.
Any
Okay,
questions?
questions from the audience? Yes, go ahead.
If the wind turbines, it's the water source, yeah. Is there like a wall that protects it, like because a boat can come?
No, because it's deep underwater.
Yeah, it can't be like
The ocean
It's like-
currents
it's
are
on
deep
the bottom.
underwater. It's not near the surface.
look like this. Look at this.
Go ahead and draw on the screen
Well,
for the purposes
it's not
of.
spinning fast enough to kill them.
Yeah.
They'd avoid things like this.
Go ahead, draw what
They're
you're
not
doing.
gonna crash
Like,
into
for example, we were worried about the fishes running into it, but we researched that they don't go fast enough to kill the fishes.
Like this. Like a boat will come like here. It wouldn't touch the water turbines. It's like the motor of the boat.
Oh, okay, okay. I didn't know what that was. I thought that was like on land.
Oh, no, that's at the bottom.
Okay, next question. Shane?
What about big ships like cargo ships?
Like I said,
Naval
it's
ships.
deep underwater. It's like the Gulf Stream. It's way underneath, near the bottom of the ocean. Ocean currents.
Question, how would the water pressure affect the structure of it?
Well, seeing it's going to be mostly solid metal, it won't affect it that much.
I mean, it's not gonna be-
What about the stress?
It's not gonna be
Yeah.
thousands of feet.
No,
No,
it's not.
gonna.
It's not gonna be like
You're-
all the way in the bottom.
It's not going to be like near the trenches.
one of these. Then you said it goes slowly, but how would it get enough locations to pick up?
Well, it's not going to go that slow.
I mean,
it's not going to go as fast as a wind turbine,
exactly.
but it's not going to. It's going to be going fast enough to generate energy.
Basically the pressure, the per square inch underwater is not sufficiently large enough to destroy whatever. Okay. Just go ahead and pause the alt peak. Just hit alt peak.
Just wonder if I start to swim around that area.
Alt
Alt
peak.
You guys talked about how it's really cheap, but you also talked about how it has to be deep in the middle of the ocean, and it has to be tethered to land using large cables.
Yeah,
Good point.
it won't be that cheap to install, but it'll.
No, I'm
make
not
up for
saying
the
it's
cost.
gonna be cheap,
Yeah,
but it's gonna be
we're
a
saying it's
reasonable price for a company to buy. You have to market like large companies. You have to target those
Are
companies.
you saying like in the long run, the electricity will be cheaper, so it'll balance out?
And it's much less expensive than installing huge towers.
Yeah,
Like
that's the
hundreds of massive
Well,
windmills.
how far out are you putting these?
Within, not in the middle of the ocean.
Like expensive pipes.
Not in the
That's
middle
like
of the
not
ocean.
like the middle of the Pacific.
It's
So,
going to be
but
relatively close to the shore compared
Basically,
to the
putting these underwater will be cheaper than their counterparts on land.
Yeah.
Okay, next question.
Do you feel that in the long run it would like even out the price that it costs to do this with the energy that's produced? Because you said it spins really slowly, so.
Well, not.
Yeah, that's a concern that I have. With
It doesn't
the
spin
changes
that
in
slow.
tide, with the changes in energy that occurs, the dynamics of the waves and all
But with
that.
the.
Will the output energy, will it be sufficient to recover the cost of?
Well, the currents are pretty
not-
pretty
Yeah,
Steady?
steady,
Yeah,
equal,
Alfredo said
night or
that
day.
they're constant. It's a
They're
constant
constantly
current.
moving.
The currents are constant.
And this and what?
No, go ahead. I just wanted to provide a little bit of feedback. I kind of like the way you guys are, or I like the fact that you hold your ground on a discussion. But just a couple of tips: never overtalk one of your teammates.
Yeah.
That looks very poor.
Or
So what I would do is, furthermore, I'd like to add to that, get that respect and that thing really crosses over if you're ever trying to sell your, whatever you're trying to do. So it does bring cooperation to the team. A couple of things, just a couple thrown out there. One, if you're trying to reduce cost, if you're trying to reduce the amount of supplies, the amount of wires going across, I'm just thinking out, just thinking outside the box here. If, like what they're saying is you have something close by, you have something that doesn't have blades possibly, have it in a place where it actually has not just current, but tidal shifts, which the shifts in the water, is it possible that you can kind of redesign the actual propeller opposed to having this, maybe have something that's doing this, that you could put pretty much anywhere by the actual, like, let's say, like a charging station for whatever you're trying to do for a house, and you have it, let's say, right in front where there's a canal or a river or something, and you can harness that energy. Okay, the reason why I'm saying that is you have a lot of issues. You have environmental issues here, you have complexity issue. I totally disagree. That is going to cost a lot more going underwater because of the labor, the complexity, the details, the rust, all the metals that you have to do have to be very specific for saltwater. So the complexity of this is extremely immense. It doesn't mean it can't happen. It just means you have to look at all the issues. Here's the thing, bottom line, in engineering, it's not, oh, can we really make it? You can probably have this and it probably down the line will be cost efficient. The question is it really practical? Is there another way you can make as much money without the complexity of all the labor, environmentalists, possible harm to fish, people, whatever. So just something to think about. How can, and I'm just giving you a suggestion, there is a technology that works underwater that does this motion, and it's just things going back and forth that doesn't necessarily need a current. And if it has a current, it's still going and it shifts. That type of technology closer to a land would probably be something you might want to look into as a possible. What's your objective? Let's state your objective right off the bat. Tell me what your objective is.
Easy, clean underwater.
No, be more specific with this. What is your objective?
Use ocean currents
To
gain electricity.
Okay, so you see that? I just gave a possibility. So if you're going to use that, you're going to compare with that. How would it rate in a matrix versus marketing, the usability, and how it would be manufactured? Just something to think about, okay? All right, I got to talk to you about this after. All right, good job. Sorry, I didn't mean to kind of...